All right, I'm putting in another video, spending some time making this just to give you some more practice with factoring quadratics. We're talking about when a is 1 and using the AC method. So if you would, before I have 5 problems, so write down the quadratic for each one, try and factor it yourself, and then go ahead and play the video and watch through, okay? So go ahead and pause now and try to factor this guy. No matter if a is 1 or not, in this case a is 1, remember a is the number right here, you can benefit from filling in this diagram. So 1 times, remember this is ax squared plus bx plus c. So ac is a times c, which is 1 times 45. And the 18 goes here. And you have to brainstorm with the vectors of 45, which are 1 and 45, 2 fails, 3 works, 4 fails, 5 works. You have to figure out which of those factor pairs adds to 18. And that's 3 and 5. I'm sorry, 3 and 15. So what does that mean? Well, when a is 1, you have the special power of being able to just use those two answers, both positive, and be done. You can be done. It's only when a is not 1 where the problem gets a little harder and this doesn't work. The reason this works is because this has to be x, and this has to be x when a is 1. So go ahead and pause, try this one. AC is negative 18, this is negative 7. Okay, we have a negative involved. The only way to multiply to get a negative is if one of these was negative. Okay, and then 18, we've got 1 and 18, 2 and 9, and 3 and 6. So because there's a negative involved here, the question changes not from which add to 7, but which are 7 apart. And that would be this pair. So it's either 2 and 9 or 9 and then 2. And I like the big number being negative because we have to end up negative. So I want to do negative 9 and 2. And because a is 1, we can go the simple route, and the answer is just x minus 9 and x plus 2. By the way, if you ever wanted to check to see if it was right because you weren't sure, you can always FOIL to check. So it'd be x squared plus 2x minus 19x minus 18. And this actually does equal this. The middle term is negative 7x. All right, one more when a is 1. Go ahead and pause. We're going to look at negative 13. And we got a 1 here, so it's going to be negative 22. We got a negative again, so one of these has to be negative. And 22, we only got 2 options, 1 and 22 or 2 and 11. And, actually, I think this was supposed to be positive. Sorry. So both of these, this is interesting. So I just changed the problem. Very, very sorry if you tried it on your own. We have to multiply to 22, but add to a negative number. How could that be possible if there's not any negatives involved? So when this happens, you actually have a double negative because you have to add those to get a negative, which will happen, and you have to multiply to make a positive number, which will also happen. And I like this choice because they do add to 13. So, sorry, kind of messed this one up, but the answer now is x minus 2 and x minus 11. Okay, again, this is positive. My mistake. Okay, so now the AC method, when we really, really need this method, we're going to take a look at negative 60 and equaling 17. So I'm seeing a negative here, which means a negative and a positive have to be multiplied together to get the negative 60. So we got a negative and a positive number. So if we look at the factor pairs of 60, which there are a lot of them, and 60 tends to show up a lot. So these are our choices. And we need to pick the ones that either, you could think add to 17, but we are going to have a plus and a minus action. So it's really a difference. So it's which ones are 17 apart. And that's going to be this pair right here. I don't want a big negative. I want 20 to be big, so it keeps a positive 17. Okay? And we can't just write down the answer and move on. When A is not 1, we're not lucky like that. So we have to use factor by grouping. So I'll separate the middle term into 2. So now I have 4 terms. And remember, we look to see, okay, first group, what do they have in common? They both have an x. And then the rest you write. And out of these two, they both have a 10. So you divide this by 10 and this by 10. And then the final step is to say that this chunk and this chunk, they both have 2x minus 3. So x plus 10 is what's left after you take this out. Let's do it one more time. I have a feeling this one was a little harder than the one we're going to do next. So go ahead and pause and try this one. AC is 24. This is A, this is C, this is B. Okay. And what I love about this one is it's all positive. When it's all positive, we don't have to worry about any negatives. We can look at the factor pairs, which are only these, and just ask simply which one of these add to 14. And that's 2 and 12. So what we would do is break apart the middle term into 12 and 2, 2x and 12x. We're going to do the same thing. So these both have a 2x. I'm going to divide both by 2x, so I'm left with a 4 and an x here, and left with nothing, or a 1 there. And then we're expecting to see this again. So if I pull out a 3, I'm going to get 4x plus 1 left, because I'm dividing this by 4, dividing this by 4. Or, sorry, divide by 3. My bad. And we're going to take that out. And this comes out, so it's kind of gone, but you write it out front. And then what's left